Hello friends, in this video we are going to study about digital camera, which is an example of the sophisticated embedded system. Here we will study that for what use the digital camera is used, how it is an example of the embedded system. We will see its block diagram and the uses of the digital camera. So let's start with our topic. The digital camera, it is an example of the sophisticated embedded systems. Means this type of system is going to require the very special microcontrollers in it. Also here, the hardware and the software included in the system, they are also very complex. And this system is used to perform some specific application. For some specific task, this system is going to be used. So digital camera, it is an example of sophisticated embedded system. Now what does a digital camera do? The camera, it is going to capture and store the images. So the first function of the camera is to capture the images. Okay, so from real world it is going to take the pictures and then it is going to store them in the digital formats. So second function of the camera is to store images in digital format. Now, as we are studying about the digital camera, so in digital camera, no film is included. And as there is no film, so multiple images can be taken in the camera. So the amount of pictures captured by the camera is also more. So here, as no film is required, so multiple. Now the amount of or the number of images stored in the camera, it depends upon the amount of memory and the bits of the pictures. Okay, so how many numbers of images are stored in the camera? It depends on the memory of the camera and also the number of bits used per image. That how many bits are used to store an image, that is also going to decide that how many images are stored on the camera. So the first feature is it is going to capture the images, and second function is that it is going to store the images in the digital format. Also, the digital camera to the personal computers, then digital camera is going to download those images captured by it into the PCs. So that is also the function of the digital camera. That system is also included in it, that it is going to download the images to the PC. Now, as I have said that the digital camera, it is going to store, capture and download the images. So we can see that it is performing multiple functions. And to perform these multiple functions or multitask, it has some requirements. Okay, the requirement is that all the systems in the camera, they should be present on a chip. Okay, so multiple processors and memories, they are embedded on one single IC. Okay, because the processor has, because such functions, so many functions are to be performed in the camera. So to perform all these functions, there are the number of processors is also more. Okay, so all these processors and all the circuitry involved in the system, that is to be embedded on a single chip. Okay, now because it is storing the images also, so for the storage of the images, the memory is used. So here the high capacity flash memory is used, so that the number of images is stored is also more. Okay, so these are the requirements in the digital camera system which are there for is to perform these multiple functions. Now let's see the designer perspective. When the designer is designing the digital camera, then what are the expectations of that designer? What is the goal of the designer which he wants to achieve while designing the digital camera? What is its main aim? So there are two key tasks in it which the designer is expecting. First is processing the images and storing them in the memory. Means the camera, it is going to capture the images, the processing is done over it, and then the images are stored in the memory. So first task is the processing images and storing in memory. So when this task is to be done, when the shutter of the camera is pressed, so at that time when the shutter is pressed, the image is captured. After that the image is processed, means the image is converted into the digital format, and then it is stored in memory. So this first task is going to involve the steps. The first step is when shutter is pressed, image is captured, converted to digital format, and then compressed and stored in internal. So this is the block diagram of the digital camera. You can see in the block diagram that it consists of various types of memories like the flash memory, the DRAM memory, the digital RAM, then the memory card. So there are different types of memories present in this system. Now the main processor is the central processing unit. Apart from this main processor, there are other processors also present in the system like the JPEG coprocessor, the camera DSP, that is the digital signal processor, and the graphics processor. So the main function of the CPU is to control all the operations, and the other special tasks, they are performed by these special processors. So the working of this host processor is to control all the operations, while all the other operations, they are performed by the special processors. Now the JPEG processor, it is used to convert the picture into the JPEG format. Then the camera DSP, it is used to change the picture into the digital format. Then we have the graphics controller. This graphics processor, it is used to do the graphics processing over the picture and to convert that picture into to display that picture on the LCD, or to give a video output after doing the encoding. Okay, so this graphics processor, it do the graphics processing over the picture. Now there are other interfaces also present in the system, like the Ethernet interface is present to provide the Ethernet communication. Then IRDA is also present, supposed for if we want to control the camera from a remote location. So for the remote control of the camera, we using the infrared, we are having the IRDA interface. Also, we are having the Bluetooth and the RS-23 interface for the advanced communication. So this is the complete block diagram of the digital camera. Also, you can see that in this diagram we are having the lens. So with the help of lens, the user is going to see the surroundings, okay, and then it is going to take the picture. So through lens, the user is going to see the image, okay. The CCD is going to capture the image. So CCD is the main part of the camera, okay, which is recording the picture, okay. So this is the explanation of all the blocks present in this block diagram, and these are the various components of the digital camera. So we have seen that the main part of the digital camera is the CCD array. The full form of CCD is the charge coupled devices. So with the help of the CCD array, the camera records the picture. Now this array, it consists of a large number of horizontal rows and vertical columns. So this CCD array is consisting of horizontal rows and vertical arrays. Now these horizontal rows and vertical columns like this, these are the vertical columns and these are the horizontal rows. So they will be forming a cell like this. And these cells are called the CCD cells. Okay. Now, in each row of cells, whenever the CCD array is used to take the picture, it is exposed to the picture. So, in this array, there are some cells which are not exposed to the picture, and these cells are used to set the offset corrections for the picture. So in this complete array, there are some cells which are exposed to picture, and those cells which are not exposed to picture, they are used to set the offset for the picture. Now in a digital camera or in a camera, the main thing is the resolution of the camera. So whenever we talk about the resolution, what will be it in the terms of the pixels or in the number of cells present in this array. So suppose that if we are saying that the resolution of the camera is 2592 into 1944 pixels. Okay. So it means that when we multiply 2592 into 1944, we will get 50388848. So whenever we say that it is the camera resolution, it means that this much number of cells are present in the CCD array. Okay, so this much set of cells are present in the CCD array. Now each set of cells or each set of pixel, it has 3 cells. Okay, whenever we say that it is one set of pixel, it means it is consisting of 3 cells. Now there is each cell for the 3 colors red, blue and green, because we know that whenever any picture is formed, then there are the 3 basic colors with the help of which an image is formed, that is the red, blue and the green. Okay, that is R, B and G. So each set of pixel is going to consist of 3 cells, and these 3 cells are for the red, blue and the green color. Now in the diagram you can see that first the lens is there. So through the lens the user is going to first clarify the picture. Okay, it is going to take the it is going to change the brightness or intensity and the resolution, and all the settings are going to be changed with the help of this lens by the user. So the picture is going to be first seen by the lens and then it will come to the CCD array. So in the CCD array we are having the cells. So each cell is going to expose to picture when the shutter of the camera opens on a user command. So when the user is going to open the shutter of the camera, then the CCD array is present and lens is present. So through the lens the picture is getting on the CCD array. So each cell on that CCD array is exposed to picture when the shutter is going to open. Okay. Now when the user is going to press the button and take the click of the picture, then the cells, they are going to capture the image or record the image with the help of these 3 colors red, blue and green. Okay, so in this way the CCD array is going to record the picture on the camera. Now, as we have discussed earlier, that the digital camera, it not only records the picture, but it also saves the picture for the future use. Also, it is going to save the picture on a PC for the permanent storage. Okay. Also, processing is done over it. Like if we want to convert the picture into different formats like JPG format or digital format, then that is also done by the camera. So processing is done over the pictures to get the picture of the brightness which we want, and the contrast and the color which we want. So processing to get the pictures of required brightness, color and contrast. Then after the recording and processing part, then the saving of that picture is done. That picture is going to be saved in the memory. So permanent saving of so saving is also done in the memory. After that, if we want to transfer those pictures into a printer, we want the display of that picture or the hard copy of that picture, or if we want the soft copy, then we want to save that picture into a we want to transfer that file into the computers. So after that, transfer files to computer or the printer. port. So in this block diagram, you can see that this part, the lens, CCD and the A to D converter, it is doing the recording. This memory part is doing the saving of the image. Then this middle part, it is doing the processing of the image. Okay. And then here, with the help of this interfaces and the LCD interface video encoder, through this either the transfer of the file is done or the display of the picture is being done. Either the picture is given as a display on the LCD panel or the video output is given here. Also, if we want to transfer this to some personal computers or to the printer, then with the help of these interfaces, it can be done. So all the purposes or the functions of the digital camera are performed by the different blocks in the system. So we have seen here that the digital camera, it is being an example of the embedded system. In embedded system, it consists of a hardware in which the software is embedded. So here also in the digital camera, we are having the hardware part, and in that the software part, that is the memory and the interfaces are present. Okay. So digital camera is an example of embedded system in which we are having an input and an output. And in this digital camera, the input is the intensity and color values for each picture. Means every picture which is taken by the digital camera, it will have different intensity and color values. So intensity and color values for each picture. Intensity and color values for unexposed area, because on the CCD array it will have different cells. Some cells will be exposed to the picture. Okay, so the intensity and color values for each picture will be the exposed area. Then the cells which are not exposed to the picture, so for that also we will have the intensity and color value for the unexposed area. Then user control inputs. So for every picture taken by the digital camera, we will have these inputs. Now in response to these inputs, the digital camera will produce the output, and output will be the encoded file for every picture. Okay, so the picture which is taken, that will be converted in the form of the exposed and the unexposed area, and the information that which of how many cells are exposed, how many cells are not exposed. So in that form there will be a file for every picture. So encoded file for a picture, then we will have the permanent store of the picture. Because that picture is being stored in the form of a file in the memory. So permanent store of the picture in the form of a file. Then either the screen display of the picture, because we can get the display also, or either we can have a file output to an interfaced computer. On a computer also we can get an output of the picture. So the output of the digital camera can be in the form of any of these. It can either be in the form of the encoded file for the picture, or in the form of permanent storage file in the memory, or as a screen display of the picture, or in the form of a file output to an interfaced computer. Now, when the digital camera it takes the picture, so what are the functions which are performed by the different components present in the system? Let's see. Now when the user starts taking the picture, then on the digital camera there is a color LCD dot matrix display, and on this LCD the user is going to see the picture of the, or it is going to see the picture of that object which it is taken. Okay, so before shooting the LCD dot matrix displays the picture. Now when the user sees the image or the picture of that object on the LCD screen, then the user can get the adjustments can be done, like any manual adjustment. If you want to change the brightness or intensity or contrast, or any color changes are to be done, then with at that time when the user is seeing the image through the LCD screen, the user can do those manual adjustment at that time. So a color LCD dot matrix, it displays the picture before shooting, and it enables the manual adjustments. So first step while taking the picture is to do the adjustments with the help of this LCD dot matrix display. Now, when the user wants to take the picture, so for shooting, it has to press a shutter button. Now, when this shutter button is pressed, then the CCD array So because after the lens the CCD array is present, so when the shutter button is pressed, the CCD array which is placed at the focus, it is going to generate a byte stream in the output. After operations by the ADC on analog output of each CCD cell. So this CCD array is going to generate a byte stream in the output. After that image is being processed, or after operations are being done by the A to D converter on analog output of each CCD cell, because the on the in the CCD array we are having the CCD cell. These CCD cells are going to give the analog output. This analog output is being converted into the digital format. Okay, so a byte stream, which is the digital output, that is being produced by the CCD array. Okay, now because according to the information in that output byte stream, a file is created after the encoding and pixel co-processing. Now after that byte stream is processed, is pre-processed and then encoded in the standard format using a codec. Okay, codec is the coder and encoder. It is the combination of coder plus encoder, that is called a codec. So in that standard format, for every picture a byte stream will be generated. So this byte stream is processed and then it is encoded in the standard format using a codec. Okay, after that encoded picture is, or encoded picture file is saved for permanent record. Okay, and where it is recorded, saved in the memory stick. Now here, after the storage of the file, if we want to display the file, then file is displayed. And or it can be copied or transferred to a memory stick, or it can be transferred to a computer. Okay, so in this way you can see that how the digital camera, it takes the picture, then it changes into or store it in the form of an encoded file, and that encoded file is then saved in the memory, and how it is displayed on the display processor, or it is say transferred to a some computers. Okay, so these are the functions performed by the different systems present in the digital camera. Now, as I've said that digital camera is an embedded system, so just like the embedded system, they have the design matrix, that there are some design standards in it, that how the camera, when it is manufactured, then what are the parameters which are to be kept in mind. So for digital camera, the design matrix are like, now the digital camera, it is a battery operated embedded system. So here the battery is to be recharged for every recharging. Battery recharging is to be done after 400 pictures. Okay. Next design metric is its resolution. Now high picture resolutions means high resolution pictures can be obtained with the options of, as I have said, 2592 into 1944 pixels, means that there are 50348 pixels or cells present in the CCD array. Okay, so 2592 into 1728, it is going to provide 3.2 m. 2048 into 1536, it is going to provide 3 m resolution. Then 1280 into 960, it is going to provide 1 m resolution. So depending upon the pixels value given to us, the resolution is also different for different cameras. Okay, now next design metric is its performance. So it is assumed that for the digital camera shooting, if it is shooting at 4 m pixels, still picture in 0.5 seconds. So if this type of pictures the camera is taking, then it can take 25 pictures per minute. So it is assumed that if the camera is having such specifications, then its performance is 25 pictures per minute. After that, we are having the next design matrix as the process deadlines. Exposing the camera process maximum 0.1 second. Okay, then user interfaces, engineering cost, and manufacturing cost. These are also some other design metrics for the digital camera. Okay, now these design metrics are kept in mind when the digital camera is being designed by the manufacturers. Now, after the manufacturing, the testing and the validation of the camera is done. So, test and validation conditions are that how the camera is tested. First, all the user commands, they must function correctly. All the buttons on the camera, whatever the user is giving the commands, that function is to be performed properly and correctly by the camera. So all user commands then on the cameras we are having different graphic and the user displays. So all these display, they must appear correctly as per their function. So all graphic displays and the menus on the camera should appear as per the program. After that, we are checking that is the camera is working properly or not. How its testing is done, then for various types of user inputs we are going to test the camera. So each task should be tested with test inputs. And we are testing the camera for 30 pictures per minute. So this is how the testing and the validation of the camera is being done. Okay. So here in this video, we studied the example of an embedded system, which is the digital camera. Just like the embedded system, it consists of the hardware and the software part. In the hardware, it has the processor and the different components are present. Just like that, digital camera is also having various processors. Okay, and also it is having the software part, that is the memory through which the instructions are given and commands are given, that which function the camera is to perform. Okay, and to the processor we are giving different inputs and we are getting different output from the camera. So we have seen that how we can represent the digital camera as an embedded system. So I hope that this topic is now clear to you. Thank you.